Welcome back. Today we're going to learn how to multiply polynomials. So today we're going to learn how to multiply polynomials. So I'm going to show you by drawing a picture of how to multiply polynomials because I think that that'll make a little bit more sense. So actually, before I get started, over here, I'm going to just show you like what 3 times 4 looks like as a picture. If I have 3 times 4, we all know that 3 times 4 is 12, but it's 3 times 4 is 12 because if I go 3 by 4, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 4, 8, 12. 4 times 3 is 12. So we're going to use that same idea to multiply polynomials now. So let's, and it says here using the distributive property. We're just going to just do all of these problems as pictures because I think they make a little bit more sense to me. I'll show you how to do the distributive property just so like you're aware because people will talk about foiling in other math classes. So I'll show you, but really just doing 2x plus 3 times x plus 5. So I'm going to separate this into 4 boxes here, where I have 2x times x. 2x times x is 2x squared. And then I'm going to do, I'm going to do x times 3 to get this 3x here. Oops, didn't mean to do that. All right, and now I'm going to multiply 2x times 5 to get the 10x in this box. And then 5 times 3 is 15. So that means that this product here is 2x squared plus 3x plus 10x plus 15. Now 3x plus 10x is 13x. And you'll notice that that 10x and that 3x, usually on this diagonal, these are almost always going to be like terms, and you can just add them up real quick. So we can do it even faster than what we just did there. Let's try the next one here. I'm going to draw a box. I've got x minus 2 and 3x plus 4. X times 3x is 3x squared. I just did x times 3x here. I did x times negative, or 3x times negative 2 is negative 6x. X times 4 is 4x. And then for this box here, negative 2 times 4 is negative 8. So I just multiplied, that's all I'm doing. I'm just multiplying this number times this number goes here. This number times this number goes here. And we do that for each combination. So I'm going to try and I'm going to combine these. So in my box, I have this first one's a 3x squared. I could write out negative 6x plus 4x like I did before, or I could just say that negative 6 plus 4 is negative 2x minus 8. If that confused you, all I did is I just added the diagonal up on my box up to get the negative 2 here. Okay, I'll do one more where I'm doing the distributive property like they set up above. What they say for the distributive property is to do FOIL, which stands for first, outer, inner, and last. So out of my two, I'm looking at this binomial here and this binomial here. I'm multiplying the first of these together, 2y times 3y. So for the first, I have 2y times 3y is 6y squared. Then it says the outer. So that must be to multiply the outside 2. So I've got the 2y and the 5, which is 10y. The inner is these two here. Negative 7 times 3 is negative 21y. And then the last is the last and the last of each term, or of each binomial. So negative 7 times 5 is negative 35. I combine these middle two terms just like before. I get 6y squared minus 11y minus 35. So that's first, outer, inner, last. It is not any different from what we did before, though. If I decided to draw my box, I'd have 2y minus 7 and 3y plus 5. The first is 2y times 3y. That's 6y squared. Hey, looks familiar. The outer, I did 2y times 5 is 10y. Looks familiar. Negative 3 times 7, or negative 7 times 3y goes here. Negative 21y, and then finally negative 35. So you can see the 6y squared, the 10. We got the 6y squared. We got the $10y. We got the negative 21y. And we got the negative 35. All the same numbers. And then if I do that trick where I add up on the diagonal, 10 minus 21 is negative 11y. We can see that that got me the final answer. I got 6y squared minus 11y minus 35. Okay, at this point, I think you probably are getting the hang of it. I think you should try pausing the video to see if you can do some of these problems here. None of these problems are that much harder, although I might be a little bit, H and I might be a little bit weird, but they're not bad. So go ahead, try the rest of these, pause the video, see if you can do them. All right, if you got stuck, you need more help here, you can watch some more. Or if you just want to see if you got them right, I'm going to draw my box for a minus 5 and 2a minus 9. Notice how I write the minus 9 by, or the plus 5. I write it next to the number because always remember that this sign goes with the number it's attached to. So my first, I have 8a squared minus 10a, and here I have 9 times 4 is negative 36a, and what is that, positive 45. I can add along the diagonal, and that is negative 46a. So my answer is 8a squared minus 46a plus 45. Okay, take a look at the next one here. I mean, we could do this with the box, we could do it with the foil. X plus 3, x minus 4. Some of you are probably wondering, does it matter if I put the x plus 3 on the top or on the side? It does not matter. You'll get the same answer because multiplication is commutative. I can swap these just like I can swap these. So I got x squared, 3x, negative 4x, and negative 12. If I add these two together, it's negative 1x. So I get x squared minus x, or minus 1x, minus 12. Over here, I should have left more room at the top. 2y minus 5 and y minus 6. I get 2y squared, negative 5y, negative 12y, and 30. These together equal negative 17y. So I get 2y squared minus 17y plus 30. Okay, and we got two more examples. I told you some weird stuff happened on these ones. The weird thing is going to happen because do you notice that these are almost the exact same, except there's just a different sign here? It just makes the answer a little bit weird. So we're going to do 5r plus 7 and 5r minus 7. I get 25r, and then that'll be, what is that, 35r, negative 35r, and negative 49. So you'll notice that this is negative 35, that's positive 35, those cancel, and my answer is 25, this should have been an r squared here. R times r squared. 25r squared minus 49. And we're going to learn about this later in a later section, but this is called a difference of squares because this is a square number, this is a square number, this is a square number, and the sign in between them is a difference. So this is a difference of squares. Same thing's going to happen here. The middle term is going to cancel out. That's what happens with the difference of squares. It's going to be 144 t squared minus 25. That's your answer. If you want to try and do the problem with the box, you can. Or if you can see the pattern, we square the first, we square the second, and the middle terms cancel out. Okay, now we're going to look at example 2a. It says we're looking at a swimming pool. So a contractor is building a deck around a rectangular swimming pool. The deck is x feet from every side of the pool. Write an expression from the total length. So, or the total area. So let's draw a picture first. Let's draw our rectangular swimming pool. There's some waves. There's me splashing around in there. Okay. So we're in the swimming pool, but they want to build a deck around the swimming pool like that. And they want to put x feet around it. There's x feet, and there's x feet on each side. So it's going to be x feet here, x feet here. There's also going to be x feet here and x feet here. So whatever I decide that the length of my pool is, and whatever I decide the width of my pool is, I'll pick those two different colors. Well, the length of my deck, I want to write an expression for the total area of the pool and the deck combined. This would be a little bit more confusing if I wanted to take out the pool, but I want the total area of this rectangle here. The whole thing. Okay? So let's look at our length. The length is going to be the length, but I have to add on this x and this x. So sorry, the length is this right here. So I have to do the length, but I have to add on these little bits here. So that's x plus x, which is 2x. And the width is going to be the width plus x, width plus 2x. Now it does say to find the area. Well, total area is length times width. So this is my total length, and this is my total width. So I have to do length times width. And I know I'm doing this right because it's in this section where I have to multiply binomials. So I'm going to probably have to multiply these binomials. Let's look at it here. It says 2b says a walkway surrounds, let me write a equals for my area. A walkway surrounds a rectangular garden. Oh, that's write an expression for the total area. Oh, it doesn't say to do anything with it. All right, that's our expression. Okay, anyway. A walkway surrounds a rectangular garden. The width is 8 feet and the length is 6 feet. So let's draw our garden. pick green because it's a pretty garden. Has a width of 8 and a length of 6. Here's my flower. And maybe it's a vegetable garden. Here's a carrot growing out of the ground. All right. So anyway, the width x of the walkway, oh, yes, this is a walkway surrounds it. The width of the walkway is x, and it's x the whole way around. So it's going to be very similar to the last problem. Write an expression that represents the total area of the garden and the walkway. So this one, the area is going to be 8 plus 2x and 6 plus 2x, because of the same reason as before. You got x here, and then x here and x here. So the 8 plus 2x, and for the length, 6 plus 2x. Easy enough. If I wanted to multiply these, it wouldn't be that hard. I would just do my area. 8 plus 2x and 6 plus 2x. 48, 12x, 16x, and 4x squared. My final answer would be 4x squared. Let's add these up. 28 plus 48. It didn't ask me to do that, but if they ask you to do it. Okay. Our last kind of problem here is going to be finding products of polynomials. So we could do this where it's a binomial times a trinomial, or we could do a trinomial times a trinomial. The way that I would recommend doing this problem is by drawing our box. So this one is going to be a little bit bigger of a box, but it's not going to be that hard. Okay, so I'm going to draw my box here. On the side, I'm going to write 6x plus 5, and then 2x squared minus 3x minus 5. And since I have 1, 2, 3 terms on the top and 2 terms on the bottom, I've got a 3 by 2 box here. Now I just multiply. 2 times 6, I'm going to have 12x cubed minus 18x squared, negative 3 times 6, and x times x, and negative 5 times 6 is negative 30x. Here I'm going to have 2 times 5, 10x squared, negative 15x, and negative 25. That pattern I told you before is still true. If I add across the diagonals, I'm going to be able to simplify this answer a little bit faster, because this is the green terms are both x squareds and the blue terms are both x's. So my answer is going to be 12x cubed from right here. 10 minus 18 is negative 8x squared. That's this green. Okay, then I have negative 5 take away 30 is negative 35x. And then finally, minus 25. If you wanted to, you could do like our distributive property way of doing it, where you do 6 times, I think this is more confusing, but you do 6 times 2, 6 times negative 3, 6 times negative 5, and then on the bottom, 5 times 2, 5 times negative 3, 5 times negative 5. This, with the box, just organizes that so we don't accidentally forget anything. Just makes it a little bit easier to avoid making a mistake. Especially on a problem like this one, where we're going to have a 3 by 3 box. Oh, this was the answer, by the way. All right, this is a 3 by 3 box because I have 3 terms on this polynomial and 3 terms on this one. So I have 2y squared plus 3y minus 1 and 3y squared minus 5y plus 2. So I'm just going to multiply 3 times 2 is 6, and y squared is y to the 4th. 3 times 3 is 9, y cubed. 3 times -1 is -3, y squared. And then 2 times -5 is -10, y cubed. Here I have 3 times -5, -15, y squared. And finally, not finally, I still have so many more to do. 5y here. The bottom row, 2 times 2 is 4y squared, 6y, and -2. I'm going to look at my diagonals again to make this problem a little bit simpler here. Or not simpler, just like, since these are all cubes, these are all squareds, and these are all just regular old y's, my answer is going to have 1, 2, 3, 4, 5 terms in it. First is 6y to the 4th. On my blue diagonal, I have -10y cubed plus 9y cubed. It's going to be a total of -1y cubed, because -10 plus 9 is -1. On my green diagonal, I have 4 minus 15, which is -11, and then -3, which is -14. -14 y squared. And then on my yellow diagonal, I have 6 plus 5, 11y, and then my last one over here, -2. So it looks complicated. It is kind of complicated. There's just a lot of steps here. But none of the steps are hard. It's just multiplying. And then I'm adding on the diagonals. You do have to be careful. Sometimes if they skip a power, see how this goes like a power of 2, and then a power of 1, and then a power of 0. If they skip a power, you can't just add on the diagonal. So like, let's say the problem was this was y cubed here instead. That would make it significant. Well, it wouldn't. The problem would be just as hard, but we just couldn't follow in the shortcut here and just add on the diagonal, because it would go 2 and then, or 3 then 1. Not a big deal. We don't have any problems like that here. But just don't just automatically say, oh, Mr. Wilma said I could add on the diagonal. You can't always add on the diagonal. All right. Pause the video. See if you can do these two. They are not hard. This one is going to be time consuming though. This one's kind of time consuming too. All right, if you want to check your work here, we have 3x minus 5 and 2x squared plus 7x minus 8. I've got 6x cubed, 21x squared, negative 24x, negative 10x squared, negative 35x, and positive 40. The diagonals are both squareds. So my answer is going to be 6x cubed. 21 take away 10 is 11. Negative 35 minus 24 is negative 59. And then I've got my 40. That is the answer. Okay, and then finally, got a 3 by 3. Again, time consuming, but not any harder than the ones we've done so far. So 4 times 1 is 4m to the 4th, 8m cubed, and negative 12m squared. Here I have negative 7 m cubed, negative 56 m squared, and positive 21 m regular old m. Finally, 5m squared, 10m, and negative 15. Now I'm going to add on the diagonals because these are cubed. These are squared. These are just my regular old m friends. All right, my answer is 4m to the fourth. 8 minus 7 is positive 1m to the third. Oh my gosh, this is ridiculous. 56? You want me to add 56 and 12 together? No, thank you. I'm going to use my calculator. Negative 56 minus 12 plus 5, negative 63. And then 21 plus 10 is 31. Not 21. Minus 15. Yeah, minus 15 at the end. All right, and that's it for that problem there. What's nice about this is we simplify as we go. So once we get this answer, I only have 1m cubed, 1m to the fourth, 1m cubed, 1m squared, 1m, and 115. Okay, that is it for that lesson. Go ahead and do these problems for homework. Remember to do all of these homework problems. It is going to be worth a bunch of points. You're going to get 100 points for your practice or for your notes, and 100 points for your practice problems. Be sure to stay tuned for the next video. Like and subscribe. Leave a comment if you have any questions. I'll try to check the comments on these. If you have any questions and you want me to answer them, just let me know. All right. Well, thank you for watching, and I'll see you next time.